Hi guys, today I'll be going through this method for my EMAth assignment video 3. So whenever you see a graph, right, you always see how it moves from the left to the right, and you see, oh, it doesn't matter going up, down, or straight, it always goes to the right. So exploiting this, the Euler's method, we can actually assume that over a very small interval, the curve behaves like a straight line. So what does it even mean? For example, an x equals 0 and y equals to 1, and your dy dx equation, which is a gradient, equals to x plus y. You find the step size. You can find a initial step size, which is h equals 0.1, where you choose your own value for the step size. So for the next x coordinate, right, when you move to the right, it's actually the initial one plus the step size, which is 0.1. So the new gradient at the new coordinate will be the previous gradient of the previous point. So this this will result in the vertical change where you just times both the vertical, which is the gradient, times the step size equals to 0.1. And then you add the previous y coordinates to it to find 1.1 as your now 1 point your now uh point with 0.1 and 1.1. So this is the graph that I've drawn where it shows that the initial point is 0 and 1 and then it goes up, up, up as a curve. So you see how it doesn't matter if it goes up or down, it still goes using the step size. And this is the equation I've given. Moving on to the Excel sheet, where I've seen that the initial value for this equation is x equals 0 and y equals to 1. So the formula for my step size is just plus 0.2 for all of them. And then the y value is using Euler's method, where I take the previous one plus 0.2 times the gradient, which is d2 here. So the gradient itself is just a copy of the question, and the exact y value is a little bit complicated, but I'll get to it later using the actual method. So the absolute error is just the exact y value and the y value, where I just minus both of them to see the difference. Okay. So let's move on to part C, where it's actually the solving part. Using Euler method, you see it's very, very long for a step size of 0.2. See, you can going on until you get y equals to x equals to 1, y equals to 2.467. Secondly, let's try using general solution. General solution is where you solve this and you times the y over and the dx over and integrate both sides to get this equation. To find c, you just take y equals to 1, x equals 0 to get c equals to half. Then you sub back when x equals to 1, your y value is 2.380. So you can see, right, during the first equation and second equation, there's an approximate error of 0.08652. This shows how that using your step size as 0.1, even although it's very, very small already, it actually changes the answer dramatically. This leads to the question, what happens when h equals 0.5? So when h equals 0.5, right, you see how little steps there are compared to this. Although there's less steps, it's actually uh, the your value at when y equals to 1, sorry, when x equals to 1 and y equals to the value is actually 2.5625. And you see the approximate error is 0.1825 compared to the general solution answer. This shows how that using a bigger step size actually hinders your answer, your final answer, as you're skipping many points. This means that at the end of the day, when you use a very, very small step size, it will take very, very long, but the answer is as close as it gets to the actual general solution answer. Thank you for your time.